Hi, I'm Hannah, and this is my partner Maya. Today we're going to take a close look on the Tohoku earthquake and tsunami that struck Japan in 2011. We're going to explain the causes of this disaster and the effects it had on the people of Japan.
On Friday, March 11, 2011, at 5:46 p.m., the fifth most powerful earthquake ever recorded struck Japan with a magnitude of 9.0. The epicenter of this earthquake is located 19 miles under the ocean and 23 miles off the coast of Japan. The damage caused by this earthquake was tremendous. This is known as the most expensive earthquake. But even more devastating than the financial loss was the loss of over 15,000 lives.
The earthquake completely destroyed over 1,260,000 buildings and severely damaged more than 1 million others. The earthquake left 400,000 people homeless. It destroyed a large dam and 78 bridges collapsed. Many fields of crops were flooded and ruined. Roads and railroads were made unusable, and at least 350 fires erupted. 91 cities and towns in Japan were affected by damage and death. The earthquake killed 15,889 people and injured over 6,000 more. 200,601 people went missing. Many significant or sacred cultural historical sites were destroyed and cannot be replaced. Even after 2 years, people are still living homeless and suffering from its effects. Let's look more in depth at what caused this earthquake.
Here with us today, we have a man who survived this devastating earthquake. He lost his home and many of his belongings. Now, can you please explain on your account what happened on this date?
Sure. When I was at my house, a violent vibration started and I headed outside and looked down at the town below the hill that my house was on. The ground was still shaking when buildings started falling and fires broke out. The earthquake lasted a whole 6 minutes, and by the end, much of the town was destroyed, including my house. After that, I got a warning that a tsunami was coming towards the town. When the tsunami came, it brought boats in from the ocean, swept people away, and brought cars piling towards houses. The waves were more than 300 feet high, and they traveled far into the city, but did not reach my already destroyed house.
What happened to you and the people of Japan after the earthquake and tsunami?
After the earthquake and tsunami came, much of the city was destroyed, including my house. The main earthquake destroyed most of my house, but the aftershocks finished it off. It also killed and injured many of the people I knew, and destroyed the town I was living in.
After this destruction, what kept your people going?
Some things that kept us going was all the help we got from other people. Many countries donated food, supplies, and shelter. One symbol of our hope to our city was the lone pine tree. A couple hundred years ago, settlers planted over 70,000 pine trees. When the tsunami hit, it wiped out all but one. This was such a big symbol of hope that when it started to die from the saltwater and soil, Japan spent $27 million to put a carbon spine inside the tree. In Japan, hope and miracles play a big part of our culture.
To be able to understand the earthquake, you need to learn about plate tectonics. The theory of plate tectonics was first established by Alfred Wegener in 1912. The theory of plate tectonics describes the motion in the Earth's lithosphere. It states that the Earth's crust is broken into sections called plates, and that they move in different directions due to convection currents in the mantle. When these plates move, mountains form, earthquakes occur, and volcanoes erupt. In general, these plates move very slowly, only a couple centimeters per year. Wegener believed that millions of years ago the Earth was one giant continent called Pangaea. He hypothesized this because the continents contained similar rock structures and the same fossils. The animals and plants were not able to travel the long distance across the ocean. He thought the only way to prove this theory is if the continents used to be together and then traveled apart. This explains how the fossils of freshwater and land animals could be in two different parts of the Earth. Another reason why he thought this is because all the continent shapes fit together like one giant puzzle. Over the centuries, the Earth has moved. Another theory, called seafloor spreading, helps explain the concept of continental drift in the plate tectonic theory. Seafloor spreading is when oceanic crust is created by magma coming up through the Earth along mid-ocean ridges. As the plates move, so does the new crust. This theory was established when scientists got together and performed an experiment where they stuck sensitive thermometers into the bottom sediments of the ocean. The instruments were then placed along and away from a ridge that had been formed by a divergent plate boundary line. The results showed that 100% of the highest heat flow values were located on the ridge, and 82% of the lowest heat flow values were located away from the ridge. The theory is supported because higher heat flow values were recorded on the ridge. This concludes that magma is coming up through the earth and creating ridges. One piece of evidence would be earthquakes. Earthquakes occur when pressure builds up on plates and causes them to have a sudden movement. There are 3 different types of earthquake boundaries: transform, divergent, and convergent. Transform occurs when 2 plates slide horizontally against each other. The next boundary is divergent. This is where the plates pull away from each other, which is also the cause of volcanic activity. And convergent can happen 2 ways. They can either collide and form mountains, or a subduction zone will occur. The Tohoku earthquake was formed by the Pacific plate subducting or getting pushed underneath one of the plates surrounding it. Because earthquakes could not occur if the plates did not move, they are proof that the theory of plate tectonics is true. The plate tectonic theory also states that volcanoes are formed by hotspots or air in the mantle rising up to Earth's surface. As pressure builds up, magma comes up through the cracks in the lithosphere and creates volcanoes. One example of a hotspot is Hawaii. Over millions of years, the Earth has slowly passed over the hotspot. In result, it has created a chain of volcanic mountains. Because the plate moves over the hotspots, the eldest volcano or seamount should be the farthest away from the hotspot. In this case, the second eldest volcano is the farthest away. It has been guessed that there was a thin part in the crust. The data supports the plate tectonic theory because it shows that the newly formed crust has moved away from the hotspot for many years. The oldest volcanoes that were once where Hawaii is today are now 5,000 kilometers away from the hotspot. Based on hotspots, earthquakes, and seafloor spreading, the theory of plate tectonics holds true. These situations plainly state that plates move because if they didn't, chains of volcanoes, seamounts, mountains, and earthquakes would not exist. As scientists have considered this thesis, most, if not all of them, support the theory of plate tectonics.
Soon after the earthquake, more than 1,000 aftershocks hit Japan. Over 20 of the aftershocks were 6.0 or above. The earthquake and tsunami left 1.5 million homes without water and around 4.4 million houses without electricity.
Since the earthquake and the aftershocks caused so much damage, it resulted in the most costliest natural disaster. The overall cost in US dollars was $235 million. Many organizations and countries donated money and supplies to help this cause. The US alone donated more than $130 million and sent 11 tons of rescue equipment to help the people. But still, after 2 years, 300,000 people are still living in temporary homes. This earthquake was so strong that it shifted the Earth on its axis up to 4 inches. It also shortened the day by 1/millionth of a second.
This disaster event caused many to lose everything except hope. Thank you for joining us today.